Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is OCR June 2023, Paper 6, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Alex draws a bar chart to show the age of the young people attending a youth club. And we've got their ages along the bottom, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and the number of young people, or the frequency up the side. Make one criticism of Alex's bar chart. Well, my criticism is that these bars here, they overlap, don't they? So you've got, if you're 5 years old, which bar are you in? Are you in the 0 to 5 bar, or are you in the 5 to 10 bar? Similarly, if you are 10 years old, are you in the 5 to 10 bar, are you in the 10 to 15 bar, and so on. So I'm going to say the groups overlap, making it unclear where certain values belong. E.g. is 5 in the 0 to 5 group or the 5 to 10 group. Okay, I always write a lot more than the bare minimum that you need to get these marked, but I don't know. I like to be thorough. Question 2a. Rearrange this formula to make u the subject. So this is one of the Newton's laws of motion, isn't it? And v is the final velocity, u is initial velocity, a is acceleration, s is the distance. But we want to make initial velocity the subject of this formula. So at the moment I've got the initial velocity squared plus this bit. When we're rearranging equations, we kind of have to go through BIDMAS backwards, don't we? So if I was working out u squared plus 2as and I knew u and a and s, I would do the index first, wouldn't I? I would square the number first, and then I would do the multiplying, and then I would do the addition finally. Okay, that's how I'd work it all out. But if I am unwinding an equation, rearranging, I need to go through BIDMAS backwards. So that means I need to deal with the addition first. I highlighted subtraction, but it's meant to be addition. So plus 2as on that side. If I take 2as away from both sides, I'm going to get v squared minus 2as is equal to u squared. Okay, so I kind of dealt with the multiplying at the same time because I don't need to multiply it out now. I'm going to deal with the index next. So I've got u squared is equal to all these things. If I square root u squared, I'll get u. And if I square u squared, I need to square root the other side as well. So it's going to be v squared minus 2as, all under that square root sign like that. So u equals the root of v squared minus 2as. Okay. Part B says a rocket accelerates at 90 meters per second and travels 270 kilometers. The rocket's final velocity is 8,000 meters per second. Using part A or otherwise, calculate the rocket's initial velocity in meters per second. Okay, right, now I want the velocity in meters per second, so I need to make sure everything is in meters and seconds. So you can see at the moment, most of them are, but I've got that distance there in kilometers. So before I do anything else, I'm just going to convert that into meters. To 270 kilometers, there are 1,000 meters in 1 kilometer, isn't there? So 270 kilometers is the same thing as 270,000 meters, isn't it? Okay. So got my SUVAT formulas, SUVAT. Which ones do I know? I know acceleration, 90 meters per second. So A is 90 meters per second. What else have I got? I've got travels 270,000 meters. That's the distance. S is the distance. So 270,000 meters. The rocket's final velocity is 8,000, so that's the value of V. So V is 8,000 meters per second. U is what I want to find, isn't it? I want to find U. Calculate the initial velocity, so that's U, that's the thing I want to find. Okay, and this particular formula doesn't have T in it, doesn't it? Not all of the SUVAT formulas have got all of the letters in. Some of them have got only 4 or 3 of them in. Okay, so now I've got all the ones I need. I've written down the formula already. U is equal to the root of V squared minus 2AS. So subbing those values in, V squared is going to be 8,000 squared minus 2 lots of A, which was 90, times S, which was 270,000, and that's all square rooted then, isn't it? Okay, so time to tap that into the calculator. Thankfully this is the calculator paper. Right, so I'm going to press the square root symbol first, and then I'm going to type in the 8,000 squared, and I'm going to minus 2 times 90 times 270,000. What is that then? Okay, that's 3,924 to the nearest whole number. I'm just going to round it off. So 3,924. That's going to be in meters per second, isn't it? Okay, is that about right? So just under 4,000 meters per second. It's accelerated, and then a bit later on it's 8,000. So it's going in the right direction. Seems all right to me. I'm going to write that down. So it's 3,924. Question 3. A bag contains 150 counters. The counters are either red or yellow. Riley picks a counter from the bag, records its colour and replaces it. Here are Riley's results. So it's got 5 red and 4 yellow then on those tallies. Use Riley's results to work out how many red counters are likely to be in the bag. Okay, so he's got 150 counters in the bag, and out of 9 drawers, he's got 5 red. Okay, so the relative frequency of red is going to be the 5 reds that he got divided by the 9 drawers he made. Okay, so that is the relative frequency we've got from the limited testing that he's done. Now, if I want to then know how many I would expect to get in the bag, then I'm going to assume that the number of reds then is going to be the number of counters in the bag times that relative frequency. I'm a bit miffed that 9 doesn't go into 150, so it's not going to be a nice number, but it is what it is. So 150 times 5 divided by 9, that's going to give me 83.3. So that comes out to be 83.3 to 3 significant figures. So I'm going to estimate, I'm going to round that down and say that there are 83 red counters, because I can't really have 0.3 of a counter, can I? So you're going to have to round it one way or the other. Seems sensible to round it down. 83. Part B says Ling uses the same bag of counters and picks the counters in the same way. And here are Ling's results. So Ling managed to get, what, 12 red and yellows. Well, that tally mark's fallen off, but that is 8, isn't it? Okay, so 12 tally marks versus 8. Use Ling's results to estimate the probability of choosing the red counter. So the same thing. Relative frequency of getting a red this time is going to be the 12 reds out of the total of 12 plus 8, 20 draws, isn't it? So the relative frequency is 12/20ths. Now both those numbers are divisible, aren't they? Both divisible by 4, so I can divide them both by 4. And that's going to give me 3/5, isn't it? So then that is going to be the probability in its lowest forms then, or its relative frequency. It's going to be 3/5. Explain why Ling's results are likely to give better estimates than the probability of choosing a red counter from the bag that Riley's results. It's really just that Ling did the experiment more often. So he actually drew 20 counters, whereas Riley only drew 9. So he did more than twice as many trials. And the more trials you do, the better your estimate of relative frequency is going to be. So I'm just going to write that down. Ling conducted 20 trials, which is more than the 9 trials that, what's his name made? What's his name? Riley. Riley made. And so will be a better estimate. Okay. Question 4a, the time taken to complete a journey. Question 4a, the time taken to complete a journey halves as the speed doubles. On the axes below, sketch a graph to show this relationship. So the time taken to complete a journey halves as the speed doubles. So let's just make a couple of notches on this graph. So I'll do like 1, 2 notches in this direction, and the same here, look, 1, 2 notches in this direction. The time taken to complete a journey halves as the speed doubles. So let's say this is speed 1 and it takes this amount of time, and then if I double the speed, the time taken then halves. So it's going to be half as high when it's twice as far up the axis. Now the type of graph this is going to be, it's going to be a reciprocal graph, isn't it? We're talking about inverse proportion. As one increases, the other one halves. So it's going to be like a reciprocal curve. So we're kind of expecting a graph that looks a bit like this. So coming down and curving like that. So it kind of approaches the axis, doesn't it, in either direction. Okay? So yeah, a graph like that, a reciprocal curve through those kind of 2 points. Not quite happy with my graph because it doesn't actually skewer the first point. Let me just try that again. Okay, that's a bit better. Okay, so obviously if the graph continued, it would kind of go like that and like that. Okay, but I'm not going to bother to draw those bits on. Yeah, so it's a bit like the reciprocal curve, isn't it? It's that part of the reciprocal curve you're drawing. Okay. Part B says it takes 40 minutes to fill a garden pond using water from 5 identical hoses. Assuming the rate of flow of the water from each hose is the same, work out how many minutes it would take to fill the same garden pond using 2 of those hose pipes. Okay, so if I'm filling pond up with 5 hoses for 40 minutes, how much time would it take for one? It's a bit like work unit. I can always call these work units. Okay, it's really, it's the amount of water that goes in this case. So if you're running for 40 minutes, 5 hoses, then 40 times 5 is 200 kind of work units that need to be done. So then if you then want to know how long it's going to take to fill it up with 2, you need to divide that number of work units by the number of hoses that you're then using then. So time then for 2 hoses, you still need to fill up the 200 worth of pond, but this time we're doing it with only 2 hoses. So 200 divided by 2, that's going to be 100. So it's going to take you 100 minutes. Question 5. The diagram represents a coastline. A, B and C are lighthouses. A boat is the same distance from A and B, the same distance from AB and BC. Use a ruler and compasses only to construct the position of the boat. Label the position of the boat clearly. Okay, so we need to do two loci constructions here. Now, the same distance from A and B, what's that? That is the perpendicular bisector of A and B, isn't it? So we need to construct a perpendicular bisector of AB. That is the loci of that one. And the second one, the same distance from AB and BC, that is going to be the angle bisector. The angle bisector of angle ABC. So these are the two constructions that we need to make. Okay, so we're going to make those two constructions, and that should pinpoint where our boat is. Okay, so first off, to draw a perpendicular bisector of A and B, we're going to draw two arcs of the same aperture, one centered on A and one centered on B. That's going to give us 2 points of intersection when those two go down, and we can then join those up with a straight line with our ruler. Okay, so that means that our boat needs to be somewhere along that line. Now, obviously it's not going to be on the land, it's not going to be in the grey bit, it's going to be in the white bit, the C part. Okay, so it's somewhere along that line, and the next thing we need to do then is to find the angle bisector of ABC. So what we do there, again, is we set our compass to a particular width. We mark on points on AB and BC, put the compass point at B and cut AB and BC to find 2 marks. And then you put your compass on those 2 marks, and then you do a second set of arcs in the middle, and then you can join B to that cross that you made there. Okay, so the boat needs to be somewhere on that line as well. So given that it's on the angle bisector and it's also on the perpendicular bisector, we can see from that that our boat must be at this point here. Okay, so marking that on the diagram, what do we need to do? Label the position of the boat. Okay, so I'm going to write boat here. Okay, job done. Question 6. At the end of each year, a driver records how many kilometers they have driven. In 2021, they drove 18% more kilometers than in 2020. In 2022, they drove 25% more kilometers than in 2020. In 2022, they drove 3,500 kilometers. Kai says, I can work out how many kilometers were driven in 2020 by reducing 3,500 by 25%. 3,500 times 0.75 is 2,625. Explain why 2,625 is not the correct number of kilometers driven in 2020. Okay, now the reason for this is I'm going to say that increasing 100% by 25% gives 125%, but decreasing 125% by 25% is not going to give you, is not 100% again. You don't get back to 100% because 25% of 125 is not 25, because 25% of 125, what's that then? So what's a quarter of 125? So 125 divided by 4, because 25% is a quarter, isn't it? That's 31.25 and not 25. Okay, so it's 31, you'd be taking off 31.25 rather than 25 away, so you're not going to get back to 100. So then part B says calculate the number of kilometers driven in 2021. So what I am going to do, I am going to have to go back to 2020 using the data I've got from the 2022 figure. So I'm going to find 2020 first by going back from 2022, and then I'm going to go forward from 2020 to 2021. Okay, so 2022 to 2020, final original multiplier for this using my triangle, FOM. Now the final is what you got in 2022 because that came second, isn't it? And that's 3,500. The original is the thing we're looking for. That's the amount we had in 2020. And the multiplier here, it was a 25% increase. So that's 100% plus 25%, which is 125%, which is a decimal is 1.25. Okay? So then the original then is going to be equal to the final over the multiplier, isn't it? Covering up the thing you want to find in the triangle. Look, covering up the original, it's final over multiplier. So subbing those numbers in, that's going to be 3,500 divided by 1.25. What's that then? So 3,500 divided by 1.25, that's 2,800. Okay? So that means in 2020 there were 2,800 miles. So if I then do, I'm going to use this space up here. So if I then calculate from 2020 to 2021, that's like this bit of information here, isn't it? Then again, final original multiplier here. What have we got going on here? So final original multiplier. So the original then is the 2,800 that we just calculated. It's this number down here. Look, that's going to be my original amount from 2020 because I just worked it out, 2,800. Okay, now the final is what I'm trying to find, how much I had in 2021, and the multiplier I was given. The multiplier is over here, that is 18%. So 100% plus 18%, that's 118%, or 1.18 then, isn't it? Okay, so this time I want the final. So covering up the final tells me it's the original times the multiplier for this one. So final equals original times multiplier. So that's going to be the 2,800 from 2020 times the 1.18% increase. So 1.18 times 2,800, that comes to be 3,304. Okay, so that's the number of kilometers driven in 2021. So that's 3,304. Question 7. The diagram shows the graph of y equals kx minus x squared plus 2, where k is an integer. Show that k is equal to 3. How am I going to show that k is equal to 3? I think what I'm going to do is I'm just going to pick a couple of points on the graph that are easy to read. So I'm going to pick this point here, which is 0, 2, because I know that lies on the graph. Maybe I'll pick this one over here as well, which is 3, 2. Okay? Now, if I sub those into the equation, they should be true, shouldn't they? So I don't know if I need one or both. Maybe I just need one. So if I've got y is equal to kx minus x squared plus 2, and I know then that y, it passes through that point I just picked off, which is at 0, 2. So subbing that in then, so 2 is equal to, now thinking about it, I'm not going to be able to use this limit because k is x is 0 and then my k term will disappear. So let's use the other one. Let's use it passing through 3, 2. So it passes through 3, 2. So 2 then, y value is equal to k lots of 3 minus 3 squared plus 2. So what's that then? So that's going to give me 2 is equal to 3k minus 3 squared is minus 9 plus 2 is minus 7, isn't it? So that's 3k minus 7. So that means 3k is 9, so k is equal to 3 then. That's right then. Okay, so k is equal to 3. And then use the graph to solve 3x minus x squared plus 2 is equal to 3. Okay, well, if k is equal to 3, then the graph we've got is y is equal to 3x minus x squared plus 2. Now, you'll notice that's the same as what we've got here. So basically we're saying, when is the equation equal to 3? Okay, so when is y equal to 3? So where's y is equal to 3? Y is the straight line here. Look, y is equal to 3 is a horizontal line passing through y is equal to 3. Let's just draw that line on. And where does that line cross the curve? It crosses here, look, and here. So what we want is the x values of those 2 points where it intersects. So we're just going to drop a line down from those points of intersection down to the axes, so I can read it off nicely. So there, I think. Okay, so I want those 2 values there and there. Now on this graph we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 10 little divisions between there and there, just double checking. So I'm 4 little squares up from 0 then. So that left limit then is going to be x is equal to 0.4. That's 0.4 there. And then up here I've got 2.1, 2, 3, 4, 5, 6. I think that's about slightly to the right of 2.6. But I'm just going to go for 2.6. I'm going to round it down to that one. So 2.6 for that. Question 8. Taylor designs a logo using isosceles triangles joined at a central point P. This is the start of Taylor's design. The complete design will have rotational symmetry of order 60 about point P. Each triangle has base B and height h measured in millimeters square in millimeters. Calculate h when B is 40 millimeters. Give your answer to 1 decimal place. Okay. Now, if this is going to have rotational symmetry of order 60, that means you're going to get 60 little triangles all the way meeting down at point P, isn't it? So that they look the same in 60 different positions. So that means that each one of these angles here is going to be 60th of a full turn, then, isn't it? And that's going to be 360 divided by 60. So each one of those is going to be, what, 36 over 6 is going to be 6 degrees, isn't it? So each one of those is going to be 6 degrees. So that's a 6-degree angle there. Okay, so knowing that's a 6-degree angle, but what we can do is we can use right angle trigonometry, just using like half of this triangle then, isn't it? Because we know that's 6 degrees there. And we know that the whole length is 40, so up to the halfway point is going to be 20 because it's an isosceles triangle. So that H line kind of divides the triangle in two. So what we need to do is to find this side here, H, don't we? Okay, so we've got the, which side? We've got the adjacent, haven't we? This is the adjacent side. And we want the opposite. This is the hypotenuse, the longest side, opposite the right angle. We don't want the hypotenuse, don't really care about the hypotenuse. So thinking about SOHCAHTOA, all the ones with H in it, we don't really care very much about because we don't want H. So that leaves us this one here, tan. Tan equals opposite over adjacent. So the tan of theta is equal to the opposite over the adjacent. Okay, so, and we worked out that the angle is 6 degrees. So the tan 6 is equal to the opposite, which is H, that's the thing we're trying to find, divided by the adjacent, which is 20. So then the height of this is going to be 20 tan 6. Okay, and what's 20 tan 6? 20 tan 6, that comes out to be 2.1-ish. So that's 2.1 then to the nearest decimal place. So that's my answer then, 2.1. Question 9. On Heidi's bookcase, the ratio of fiction to non-fiction books is 2 to 3. Heidi removes 2 fiction books from the bookcase. The ratio of fiction to non-fiction books is then 5 to 8. How many books are left on the bookcase in total? Okay. So we have this ratio of fiction to non-fiction, don't we? And it starts off in the ratio of 2 to 3. We then remove 2 fiction books, so minus 2 fiction books, and we end up with the ratio of 5 to 8. Okay? Now, what we need to do is we need to consider the fact that the non-fiction books, they have not changed, have they? So the number of fiction books didn't change from there to there. But they're not easily comparable because we've got 2 different ratios with 2 different values for non-fiction, 3 and 8. So what I'm going to do is I'm going to re-express each one of those ratios, but in with a compatible number on the end there. So 3 and 8 both go into 24, isn't it? So that's the same thing as if I times this up by a factor of 8 then. Okay, so 2 to 3 is going to be the same thing as the ratio of 16 to 24. And then the other ratio, if I times it up by a factor of 3, then that is going to be in the ratio of 15 to 24. Okay? So you can see now then that these two are the same, 24 and 24. So when we subtracted those 2 books, then the number here went down from 16 to 15. So the number of shares of fiction books went down from 16 to 15. So that tells me that 1 share is going to be equal to 2 books then, isn't it? Okay, so if the number of shares of fiction books went down from 16 to 15 when I took 2 books away, then 1 share is equal to 2 books. Okay, so now if I take that ratio of 15 to 24 and times it by 2, then I'll get the number of books of each type then, won't I? So that means that there must have been 30 fiction books and 48 non-fiction books. Okay? So in that case, how many books are there altogether left on the shelf? So books remaining is going to be 30 plus 48. That comes to 78 books then, isn't it? So that's 78 books. Question 10. Show that 95 is not a prime number. Okay, well, all we need to do to show a number is not a prime is that another number divides into it other than 1 in itself. And it ends in a 5, doesn't it? So clearly it's going to be divisible by 5. So 5s into 95 go... well, I've got a calculator actually, I didn't do that. So 95 divided by 5... probably just do it in my head anyway. 95 divided by 5, that is what, 19? So 95 has factors 5 and 19, so cannot be prime. Now I don't have to find all of the factors, do I? As long as I find one other factor that isn't 1 or 95, then it's not prime, so that's enough. Okay, so then 2,000 and 8,750 are written below as products of their prime factors. Yes, they are. Find the highest common factor, HCF, of those 2 numbers. Okay, I'm just going to write this out long because I think it's easier to do HCFs when you're showing all the individual factors and you haven't got them grouped together like that. So that's 2 times 2 times 2 times 2, that's 2 to the 4 times 5 to the 3 is 5 times 5 times 5, and this one is 2 times 5 times 5 times 5 times 5 times 7. Okay, so then the HCF is going to be all of the prime factors that are in both. Okay, so I can see that there's a 2 in both. There's also a 5 in both, and another 5 in both, and another 5 in both. And then the others don't pair up, do they? Okay, so I haven't got any more pairs than those. So each of those pairs is going to contribute to the HCF. So I've got 2 and 5 and 5 and 5. So that's equal to 2 times 5 times 5 times 5. That is equal to 250. Okay, it's 250. Now there is a feature on the new Casio calculator that allows you to do HCFs with pretty easily. So probably a good idea just to double check your answer using the HCF feature on the calculator. So just clicking on catalog, going to number calculations. Now you've got GCD and LCM being shown here. Now LCM is obviously just LCM. GCD actually stands for greatest common divisor. So that's another way of saying highest common factor if you think about it. So highest is the same as greatest, common is common to both of the things, and divisor or factors are just different words for the same thing really, aren't they? So yeah, so greatest common divisor, GCD. So if I press that button and then type in 2000, and then I need to press the common key, which is here above the right bracket, and then I'm going to put the second number 8750, close bracket, press execute. You should see that that comes with the 250 that I found earlier. Okay, and part 2 says write 2 times 10 to the 12 as a product for its prime factors. Well, if you think about it, 10 is equal to 2 times 5, isn't it? And if I had 100, that would be 2 squared times 5 squared, okay? Because, well, 2 times 5 is 10, another 2 times 5 is 10, and then 10 times 10 is 100. So essentially, and that's the same thing as 10 squared, isn't it? So whatever the power is, that's the number of 2's and the number of 5's you're going to get. So 10 to the power of 12, that's going to be 2 to the power of 12 times 5 to the power of 12. And then so 2 times 10 to the power of 12 is going to be 2 times 2 to the 12 times 5 to the 12. And then you can just kind of combine those two together, can't you? 2 times 2 to the 12 is 2 to the 13. So the final answer is 2 to the 13 times 5 to the 12. Question 11. The diagram shows a quadrilateral PQRS. Yes, it does. PS is 10. That's already on the diagram. Look. Angle QPS equals angle PSR is equal to 90. That's already on the diagram as well. SR is equal to 6 centimeters longer than PQ. That isn't on the diagram, is it? So we don't know how long PQ is, but I know that SR is 6 longer than it. So in this case, it's always a good idea to use a little bit of algebra, isn't it? So I'm going to call PQ equal to X, and then SR is 6 longer. That's going to be X plus 6 in that case, 6 more than X. The area of the quadrilateral PQRS is A. Write a simplified expression for the length of PQ in terms of A. You must show your working. Okay. Right, so what have we got? We've got the area of a trapezium is a half times A plus B times H. So it's the two parallel sides added together and divided by 2. You're averaging them out, and then you're multiplying them by the distance between them. Okay, so what I want to do then is sub in what I know. So A I don't know, I'm just going to leave it as A. That's half. Now side A was this side here, look, and we called that X. So let's call it X. Plus side B, we said that was this side here. So that's X plus 6. Okay, and then H, distance between them, that's that distance, it's the 10 there, isn't it? Okay, so that's 10. So we're going to be timesing that by 10. Okay, right, I'm just going to half the 10, make 5. Okay, there's one little quick move, get rid of the half straight away, and then I'm going to add the two terms together in X inside the bracket to give me 5 lots of 2x plus 6. Okay, just brought the 5 to the front. So that's how we normally write it when we've got a multiplier of a bracket. You should have the multiplier at the front rather than at the back. And then I'm just going to multiply out that bracket. 5 times 2x and 5 times 6. That's going to give me A is equal to 10x plus 30. Now, I want to have this as an expression for PQ. Remember, PQ is the length x, so I want to make x the subject of this, basically. So I'm going to move everything to the other side, so it's got x is equal to. So taking the 30 away first, a minus 30 is equal to 10x. And then dividing through by 10, I'm going to get x is equal to a minus 30 over 10. Okay? Now, is that as simple as it can be? Probably. I suppose you could write it as a over 10 minus 3. I'm not sure that's any more simple. I think either of those forms is probably acceptable. I was thinking I would just end there, but if you did write it like that, that's also fine. But one isn't more simple than the other. They're just equivalently simple. Question 12. A box contains 200 matches. Correct to the nearest 10 matches. Complete the error interval for n, the number of matches in the box. Okay. Right, so if I've got 200 matches nearest to the nearest 10 matches, now if this was a continuous thing, then 10 more matches than 200 would be 210. 10 fewer matches than 200 would be 190. So the ones that round up to 200 are going to be halfway in between, isn't it? So 195 would round up to 200. 205 would round up to 210. Now, if this was discrete data, we would just use 205 as the upper limit anyway. But this is discrete data, isn't it? You can only have a whole number of matches. You can't have part of a match. So here I am going to use the lower bound of 195, but I'm not going to use 205 here. I'm going to use 204 because these are whole numbers only, aren't they? And 205 rounds up. Okay, so it's 195 to 204. Now, if this wasn't number of matches, if it was a continuous problem, then the range would be 195 is less than equal to n, which is less than 205. You just use the upper bound, but it isn't. It's discrete data, so that's what makes the difference. We don't use 205 here. We actually use 204. Right, and then part B says the box is a cuboid with length 7 centimeters, correct to the nearest centimeter. Width is 5 centimeters, correct to the nearest centimeter. And the volume is 248 centimeters cubed, correct to the nearest centimeter cubed. Show that the smallest possible height of the box is 6 centimeters. Okay, so I'm going to do what I did a minute ago. I'm going to round off each one of these to their, well, I'm going to find the upper and lower bound of each one of these, aren't I? That's what I'm going to be doing. Okay, so for this one, 7 correct to the nearest centimeter. On a scale, 1 up from 7 would be 8, 1 down from 7 would be 6. The numbers then that round to 7 are going to be the ones halfway between those or closer. So that's like 6.5 and 7.5 here. This is continuous data, so 7.5 is the upper bound. And then the width is 5 to the nearest centimeter. So again, 5, 1 more is 6, 1 less is 4. The ones that round to 5 are going to be halfway between those or closer. So we're talking here of 4.5 and 5.5. And then finally the volume of 248. Again, that's to the nearest centimeter cube. So 1 up from there would be 249. 1 down would be 247, and so the ones that would round to 248 are going to be the ones halfway between them or closer. So that's 247.5 and 248.5, halfway between those, isn't it? Okay. Right, so I want to find the smallest possible value of the height of the box. Okay, so the smallest possible height, remember that volume of a box is equal to length times width times height. So if I want to find the height from this, I need to rearrange, make h the subject, isn't it? So dividing both sides by L and W, I'm going to get h is equal to V divided by L times W. Okay, so then if h is equal to V times L, V divided by L times W, to find the smallest possible value that I can get for h, I'm going to have to pick the smallest possible value of v, okay? But I'm going to have to pick the largest possible value of L and the largest possible value of W because they ended up on the denominator. And if you think about it, the smaller fractions have larger denominators, don't they? Because you divide them through by that denominator. So a half is bigger than a quarter. A quarter is smaller than half because 4 is bigger than 2. So to make the smallest possible value, you want to use the largest possible denominator for a fraction. Okay, so I'm going to use h is equal to the lower bound of v. So I'm going to use the lower bound of v, the 247.5, and I'm going to use the upper bound of, I haven't labelled these, have I? This was L, this was W, this was V. So I'm going to use the upper bound for W, which was 5.5, and I'm going to use the upper bound of L, which was 7.5. Okay, so subbing all those in, lower bound of V is 247.5 divided by upper bound of L, 7.5, times the upper bound of W, which is 5.5. Okay, so what's that then? 247.5 divided by 7.5 divided by 5.5. That comes out to be 6. H is equal to 6, as required. Question 13. A running club records the distances run by each member during December. The results are shown in the histogram. So part A says 18 members run less than 20 kilometers. Work out the number of members who run more than 30 kilometers. Now you'll notice on the graph, the frequency density scale is blank, isn't it? So we don't know what the frequency densities are there at the moment. But we can use this bit of info here that they give us to find out. So 18 members run less than 20 kilometers. So that 18 members running less than 20 kilometers is this bar here, isn't it? It's this bit. Okay, that's the bit that's equal to 20. So 18 is the frequency, and it's the area of the bar on a histogram that is proportional to frequency. So here we know that the area is equal to 18. Okay, and then we would get that, the area, by multiplying the class width, which is 20, by the frequency density that we don't know because the scale is blank. Okay, so 20 times f is equal to 18. That means that value there, the f value, is going to be 18 divided by 20 then. 18/20ths. That's the same thing as 9/10. So that is 0.9 then, 9/10. Okay, so you'll see that's like 18 little divisions up. So that would mean this would be 1.0 and this would be 0.5 on that line there. So this scale is going up in like 0.5, so that would be 1.5 to 2.5 up that scale like that. Okay, that kind of all works out. So then work out the number of members who run more than 30 kilometers. Well, 30 is here, look. So more than 30 is going to be all the people in this bar plus all the people in this bar here then, isn't it? They're all the people who run more than 30. Okay, so what we need to do is work out the frequency of these two bars. But now that shouldn't be a problem because we know the class width and we know the frequency densities now. So the area of this one is going to be the class width of 10 multiplied by the height of 2. So that should give us 20 runners. And on the other one, the class width goes from 40 to 80. So that's got a class width of 40 times a height of, it's like 1, 2, 3, 4, 5, 6 little boxes up. Okay, so remember, so that's, what's that going to be, 0.3 then? I think that's going to be 0.3, isn't it? If it's 6 boxes, each one of those boxes is going to be 0.05 because there are 20 in one. Okay, so that's 3 times 0, so that's 40 times 0.3, which is going to be 12 then, isn't it? So there are 12 runners in that section. Okay, so work out the number of members who run more than 30. It's going to be 20 plus 12, which is equal to 32. And then part 2 says, Finley says To estimate the range, I subtracted the smallest possible value from the largest possible value. So 80 minus 0 is 80 kilometers. Explain why Finley's method is likely to overestimate the true value of the range. Well, I think what Finley has done is probably the correct way to measure the range of this data with the data we've been given, but it makes the assumption that the highest person ran the highest amount of that bar. It means that someone ran 80 kilometers. That's what it assumes. Because this bar spans from 40 to 80 and we're using 80, we're assuming one of those 12 people in that category ran 80. But it's not necessarily the case. I've got the bar, if you had like a tick box and you had to say how many miles you ran this month, and you had like the 0 to 20, 20 to 30, 30 to 40, 40 to 80 box, there's no reason to think you'd actually run any one of those 12 people actually ran 80. But it's the assumption that we've made. Similarly, at the other end, we're assuming that 0 comes from the fact that one of these 18 people in the yellow box ran exactly 0 miles. Which is unlikely, isn't it, from a running club that one of the members didn't run at all. So, maybe they didn't. Maybe they, broke their leg that month and didn't run anything. But, it's an assumption we've made. Okay, so, or the assumption Finley's made. Finley has made the assumption that one runner has run 0 miles and one ran 80 miles, but as the data is grouped, we cannot know this for sure, and it is likely that the highest and lowest values were not these exact values. Part B says this box plot shows the distribution of the distances run by each member of the running club during July. During December, the median running distance was 30 kilometers and the interquartile range of the distance run was 20 kilometers. Make two comparisons between the distances run during December and the distances run during July. Okay, so we know that the median and interquartile range from December, it's given in the text, and we've got the data for July shown as a box plot, so we should be able to read off those two values from here. So members ran further on average in December. Just going to put in brackets what it was. So it was 30 kilometers than in July, which was 26 kilometers. Okay, so members ran further on average in December, so that's one thing we can say. The other thing we can talk about is the variation of the group. So we can see in July that the interquartile range was 36, whereas in December it was 20. So there's a lot more variation going on in July than there was in December. So there was much greater variation in running distances in July. And again, I'm just going to say IQR is equal to 36 compared to December. And again, I'm just going to quote the data. IQR is equal to 20. Okay, just to back up what we're saying. So there was much greater variation in running distances in July interquartile range 36 compared to December interquartile ranges 20. Okay. Question 14. The diagram shows a square-based pyramid ABCD. O is the center of the base. The pyramid has a base length of 20 and each sloping edge has a length of 14.5. Draw the plan view of the pyramid on 1 centimeter grid below. Okay. Plan view is like you can either think of a plan view as like a bird's eye view looking down upon the shape, okay, or you could consider it as like, you know, if you had like a cookie cutter view. So if you picked up the shape and plonked it into some sand, what's its footprint going to look like? Okay. Now this is a square-based pyramid, so I'm expecting its plan to be a square. Okay, and it's 20 by 20, so we're going to be using 1 centimeter represents 4 centimeters in reality. So if it's 1 to 4, then my 20 centimeters of the pyramid is going to be what? It's going to be 5 centimeters, isn't it? Because that's 5 times bigger, so timesing that by 5, I'm going to get 5. Okay, so 5 centimeters on my scale is going to be the same as 20 centimeters on the diagram. So basically I just need to draw a square which is 5 by 5 on my diagram. Okay, so I'm going to draw a square which is 5 by 5. This thing does not draw on lines very well. Okay, there we go. So that's 5 by 5. So that would be A, B, C, D, and we'd get the point O in the middle like that, wouldn't we? That would be the vertex that you would see in the middle. Okay, so that's my plan of the pyramid from above. I think I'm just going to add in the slant lines as well across the pyramid, because I guess you'd be able to see those as well, wouldn't you? From above. So let's just add those diagonals in. Okay. Part B says calculate the volume of the pyramid. You must show your working, and we're given the formula of volume equals of the pyramid is 1/3 times the area of the base times the perpendicular height. Okay. Now, got a slight problem in here in that we don't know the perpendicular height. Perpendicular height is the distance OE, isn't it, from the base to the base of the pyramid up to the vertex at the top. Okay. So how are we going to find that H? Well, if you look here, we've got a triangle AEO, this triangle here. So that one there has got H as one side, and we know this side here, we know AE is 14.5, don't we? So we know that distance, but we don't know AO in that there. We need to work that out first. Okay, so we need to work out AO. We can do that because we can then form a second triangle, and look at this. If I imagined ACB, this second triangle here, AC passes through O, doesn't it? It's halfway. So, you know, that distance is the same as that distance there. So if I can find AC, then I can halve it and find AO, and then I've got AO and I've got AE, and I can use Pythagoras theorem to find H then, can't I? Okay, so I'm going to use the blue triangle first. So I'm going to say in triangle ABC, the blue triangle, just sketch it. Okay, that's my right angle. So A, B, C. A is 20, BC is 20. We want to find that AC, don't we? So AC squared, the long side or the hypotenuse, is equal to the other two sides squared, isn't it? So it's 20 squared plus 20 squared. Well, 20 squared is 400, and 400 and 400 is 800. So then AC is going to be the root of 800, isn't it? 400 plus 400 is 800. So what's the root of 800? In fact, I'm not going to bother. I'm just going to leave it as that for now. Or am I? Yeah, let's just leave it like that. I can always work it out later. So then AC is 800, and then AO then is going to be a half of root 800, then, isn't it? Okay, because it's half the distance of AC. Now I'm going to switch now into the green triangle. So that was the blue triangle, wasn't it? Okay, I'm going to switch to the green triangle now. So green triangle is AOE. So in triangle AOE, so there's the right angle. We know that the AE is 14.5, and we know AO is what we just found. It's half of root 800, isn't it? And we want to find H, which is that OE side there, isn't it? Okay, so again, using Pythagoras theorem, but I want to find the shorter side this time, don't I? So it's going to be H squared, the height of the pyramid, is going to be 14.5 squared minus half of root 800 squared. Right, so half squared is a quarter, and root 800 squared is 800. So that second bracket is just a quarter of 800. It's 200. You could check it on your calculator if you like, but I'm pretty sure that's right. So then 14.5 squared, that is 210.25. So I'm going to get 210.25 minus 200. So 210.25 minus 200, and then square rooted to find the length of H. Root answer is about 3.2. I'm going to write down 3.2, but again, I'm going to use my full calculator display value when I do the next part. Okay, so I've worked out H now. It's 3.2-ish. So then the volume of my pyramid is going to be a third times the area of the base times the height of the pyramid, okay, which is a third of, what's the area of the base? Well, the area of the base is a square, isn't it? It's going to be 20 squared times the height, which we just worked out to be 3.2-ish, whatever the calculator display is. So then that's what I'm going to type into my calculator. I'm going to use the last calculated value, and I'm going to times it by 20 squared, and I'm going to divide it by 3, and that comes out to be 426.87, which I'm just going to round off to 427. That'd be 3 significant figures, wouldn't it? And I think that's plenty accurate enough. So I'm going to say that's equivalent to 427 cubic centimeters to 3 significant figures, and that's going to be my answer then, 427. Okay. Question 15. Two bottles are mathematically similar. The small bottle holds 0.5 litres and has a height of 35 centimetres. The large bottle holds 2 litres. Calculate the height of the large bottle. Okay. So we've been given the heights and we've been given the capacity, which is equivalent to volume of these shapes, isn't it? So what is the ratio of their volumes? Ratio of volume. We've been, let's say, we've been given capacity of both from the small to the large, but that is equivalent. You know, you can convert it to volume pretty easily. So that's 0.5 to 2 then, isn't it? So that's in a ratio of 1 to 4. Okay, and we want the ratio then of their heights. Ratio of heights. So we can work out the second one from the height that we know. Okay, now the thing is about similar shapes is that if you've got two shapes that have heights in the ratio of a to b, then their volumes are going to be in the ratio of a cubed to b cubed, aren't they? So 1 to 4 should be a cube of what it is here. So if I want to find, so the ratio of the heights basically is going to be the cube root of 4, whatever that is. It's not a very nice number, but it's going to be the cube root of 4, because if you cube cube the cube root of 4, you'll get 4, won't you? If you cube 1, you'll get 1. So if I cube 1 to cube root of 4, I'll get 1 to 4 for the ratio of the volumes. Okay, so I know that, and so I'm going to use that then to work out what the height of the larger bottle is then. So height larger bottle is going to be the height of the smaller bottle, which is 35, times the scale factor of 1 to cube root of 4 then, isn't it? So I'm going to times 35 by the cube root of 4. What's that then? So 35 times cube root of 4. I make that 55 and a bit. I'm going to round it off to 55.6, I guess. That's going to be 55.6 centimeters then, 55.6. Question 16. The price of a seat on flight, which is in P pounds, is given by P equals 49 times 1.009 to the power of N, where N is the number of seats sold on this flight. So this is like a growth and decay question, like compound interest, where every price of every ticket is going to be slightly more, depending on how many seats have already been sold. So it says part A, write down the percentage increase in price of the second seat sold compared to the first seat sold. So P1, the price of the first ticket sold, that's going to be £49 times 1.009 to the power of 0 then, isn't it? Because when you're selling the first ticket, then there have been no tickets sold up to that point. And any number to the power of 0 is 1. So that's just going to give you £49 for the first ticket. Now, ticket number 2 is going to be 49 times 1.009 to the power of 1, because when you're selling the second ticket, you've already sold one ticket. Okay, so you can see then that's going to be 1.009 times bigger than the first price of the first ticket. So the first ticket is 49, the second ticket is 49 times 1.009. Okay, so what is the percentage increase for the second ticket? It's going to be 1.009 as a percentage would be 100.9%, wouldn't it? So what is the percentage increase? If it's gone from 100% to 100.9%, that's a 0.9% increase, okay, from ticket 1 to ticket 2. And then it says, show that the price of the 40th seat sold is less than £70. Okay, so the price of seat 40, that's going to be 49 times 1.009 to the power of what? If it's seat 40, that means I would have sold 39 seats before I got to seat 40. So it's going to be 49 times 1.009 to the power of 39. And what's that on my calculator then? So 49 times by 1.009 raised to the power of 39. Okay, and that comes out to be 69.494. 69.49. I'm going to round it off to the nearest penny. So you can see that that is about 50p less than £70, isn't it? So ticket is less than £70. Okay, we proved it. We've shown it. Question 17. The kth term of a sequence is r to the power of k, where r is not equal to 0. The sixth term is equal to 3 times the second term. Find the value of r, given your answer correct to 3 decimal places. Right, so the kth term, I use the notation UK for the kth term, usually use UN, but they're using K here. That's equal to r to the power of k then. Okay, so for the sixth term, that's going to be U6, that's going to be r to the power of 6 then. And the second term, U2, is going to be r to the power of 2. Okay, but we're told that the sixth term, u to the power 6, is 3 times the second term. 3 lots of u to the power of 2 then, isn't it? So u to the power 6, which we just worked out was r to the power 6, that's equal to 3 lots of u2, the second term, which we just said was r squared. Okay, So r to the power of 6 is 3 lots of r squared. Dividing both sides by r squared, I'm going to get r to the 6 over r squared equals 3. And r to the 6 divided by r squared is r to the 4. So r to the 4 is equal to 3. And therefore r is going to be the 4th root of 3. Okay, so we need to give that to 3 decimal places then. So what's the 4th root of 3? So the 4th root of 3 to 3 decimal places, that's 1.316 then, isn't it? So r is equal to 1.316. Question 18a, describe fully the graph of x squared plus y squared equals 20. Well, I know that any graph of the form x squared plus y squared equals r squared, that is a circle of radius r, okay, centered on the origin. Okay, so it's got a radius of r and it's centered at the origin. So that is how I'm going to describe it then. But I know that this radius, r squared, is going to be equal to 20, because if I compare this with this, look, 20 and r squared, these are going to have to be the same thing. So then r is going to be the root of 20 then, isn't it? It's going to be root 20. So it's a circle with radius root 20 centered on the origin. So describe fully the graph. It is a circle, center, origin, radius of root 20. That's how I'm going to describe it. A circle, center, origin, radius of 20, root 20. Part B says the graph of y equals 3x plus 10 intersects the graph of x squared plus y squared equals 20 at 2 points. Use an algebraic method to work out the coordinates of those 2 points. Okay, so x squared plus y squared equals 20. Well, root 20 is roughly, it's going to be about 4 and a bit, isn't it? Because 4 squared is 16, 5 squared is 20. So if I was going to sketch this on a graph, okay, then I'd have a circle centered on the origin. Okay, x and y. Okay, so that's going to be slightly more than 4, slightly less than 5, isn't it? Okay, so 5 is about there. Okay, and then, so I've got the line y equals 3x plus 10. So y equals 3x plus 10, that's going to be passing through. This has got a y-intercept of 10, so it's going to be passing a bit higher up on my graph. Okay, it's going to be up here, isn't it? So if that's 5, then it's going to intersect like that, and it's going to be quite steep. It's going to have a gradient of 3. So this line then is going to come down and with a gradient of 3, and it's going to skewer this graph in 2 places. Kind of there and there. I don't really know. They might be both above the axes. They might be both below. Well, I think they could be both below. One's going to be above the axes for sure. One might be above or below. I'm not quite sure. Okay, so they're the 2 points I need to find. I need to find that point there and that point there, don't I? Okay. Now you can find points of intersections by equating the graphs and solving them simultaneously, can't you? So I've got the equations x squared plus y squared equals 20, and I've got the equation y equals 3x plus 10. So I'm going to call this one equation 1, I'm going to call this one equation 2, and I'm going to substitute equation 2 into equation 1. So where I see the y in equation 2, I'm going to write it at that point in the equation for 1. Okay, so x squared plus y squared, or y is 3x plus 10 squared, is equal to 20. So just multiplying out that bracket, I'm going to get x squared plus, now I'm going to be using the perfect square identity to multiply this out in my head. So I know that a plus b all squared equals a squared plus 2ab plus b squared. I just remember that as an identity, and so it just makes expanding these a little bit quicker. So I know that here a is 3x, so 3x squared is going to be 9x squared, isn't it? And then I need 2ab, 2 times the first term times the second term. Well, 3x times 10 is 30x, doubled is 60x, so my middle term is 60x. And then the last term is going to be 10 squared, it's going to be 100. Okay, and that's equal to 20. Okay, so you can see I've got a quadratic going on now in x squared. So x squared plus 9x squared is 10x squared. And then I've got 60x plus 60x. And then 100 take away 20 is 80. So that's equal to 0. So I got 10x squared, 60x, and 80. These are all quite big numbers, but they're all multiples of 10. So just dividing through everything by 10 just to make things a little bit easier. So that's going to be x squared plus 6x plus 8 is equal to 0. Okay, so can I factorize that? I hope so. So factor pairs of 8, I've got 1 and 8, 2 and 4. Which one of those pairs adds up to 6? It's this pair, isn't it? It's 2 and 4. So I'm going to get x plus 2 and x plus 4 is equal to 0. Okay, so that gives me solutions. X plus 2 is equal to 0, give me x equals minus 2. And I'm going to get x plus 4 is equal to 0, give me x equals minus 4. Okay, so I know my x coordinates are going to be minus 2 and minus 4. I need the y coordinates as well. So when x equals minus 2, I'm going to sub into the easy one and 2. I'm going to sub into equation 2 to find y. So y then is equal to 3 lots of minus 2 plus 10. What's that then? 3 minus 2 is minus 6 plus 10 is 4. So that's going to be minus 2 goes with 4. And when x equals minus 4, what's that then? Y is going to be 3 lots of minus 4 plus 10. 3 lots of minus 4 is minus 12 plus 10 is minus 2. So that's minus 4 minus 2. So you can see actually one was above the axes and one was below the axes. So that point up there, look, is going to be the minus 2, 4, 1, and this one down here is the minus 4, minus 2, 1. Now before you do move on, it's always a good idea just to think about the values you found on the diagram, think, well, does that look about right? And for me, that does look about right. That was what I was expecting to happen. Okay, so they look very consistent with my diagram. I'm happy that they look okay. This is a complicated problem. It's better to do these visual checks for yourself before you move on in the exam. Better to find out at the exam you've made a mistake than 2 months later when the results come back. But I'm pretty confident with those. They look pretty good. This sits well with the diagram, so I'm going to move on. Question 19, got some fun with surds here. Show that root 11 times root 22 is equal to 11 root 2. Okay, so when you've got two numbers under a root, you can multiply together. That's the same thing as them all under one square root of 11 times 22, isn't it? And 11 times 22 is, what's that, 220, and another 22 is 242, isn't it? So that's the same thing as root 242. I'm just going to start with the left hand side. So root 11 times root 22, just tie this up a little bit. That's equal to that, which is equal to that. Now, are there any square factors here? Hopefully there are, because I want to break it down into 11 root 2. But I've spotted 242 is double 121, isn't it? So I could express this as 121 times 2, and that's the same thing as the root of 121 times the root of 2. But the root of 121 is 11, so that does give me 11 root 2. Look. Okay, so there we go. I've got my 11 root 2. I started with the left-hand side here, and I kind of saw it all through, and I ended up with the right hand side there. Okay, so it worked. Part B, show that root 11 over 13 plus root 22 can be written in that rather horrendous looking form there, where a and b are integers. Okay, now basically what we need to do here is rationalize the denominator. The second form has got a rational denominator of b, whereas the first one has got an irrational denominator which has got a root 22 in it. Okay, now when you've got something of that form, a plus root b, on the bottom, and you want to rationalize it, the easiest thing to do is to times top and bottom by the same expression but with the sign flip. We call it the complement. So the complement of 13 plus root 22 is 13 minus root 22. Okay, so if I times top and bottom through by 13 minus root 22. Now, why on earth would you want to do that? Well, if you've got 13 times 13, you're going to get 13 squared. Then you're going to get plus 13 root 22 minus 13 root 22, which will cancel, and then root 22 times root 22, which gives you 22. So when I multiply the denominator together, I'm going to end up with 13 squared minus 22. Okay, that's what I get. That's why we multiply it through by the complement. I'll work that out in a second. So then on the top, I'm going to get root 11 times those two things, aren't I? So I'm going to get root 11 times 13 minus the root of 22. Okay, now what's that equal to? That's equal to, well, the bottom part, root 13, the bottom part, 13 squared is 169. Take away 22. That's going to give me 169, 159, 49, 147, isn't it? So that's 147 on the bottom. On the top, I'm going to get 13 root 11 minus root 11 times root 22. Now that looks familiar. Yeah, it does look familiar, doesn't it? It's just what I worked out a minute ago. Root 11 times root 22. I've already simplified that in the first part of the question. So I can replace root 11 root 22 with 11 root 2 because I worked it out earlier. So that's the same thing as 13 root 11 minus 11 root 2 all over 147. Okay, and now 13 and 11 don't have any common factors, so I can't factorize any numbers out and cancel it with what's in the bottom. So I think that's it. My A is 13, my B is 147, and the rest is the same as what it is up there, isn't it? So I've kind of done it. That's it. Question 28, write 2x minus 5 times x plus 4 in the form of two lots of x plus a all squared minus b. Okay, so that is the completed square form. So it looks to me what I need to do is multiply out that bracket and then complete the square on what I get. Okay, and then leave it in completed square form after that. So I'm going to start with the factorized form of the quadratic, remove the brackets, and then complete the square. Okay, so let's start with 2x minus 5 x plus 4. So using FOIL, first outside inside last, or whichever way you do it, I'm going to get 2x times x, which is 2x squared. I'm going to get 2x times 4, which is 8x. I'm going to get minus 5 times x, which is minus 5x. I'm going to get minus 5 times 4, which is minus 20. Okay, so that tidies up to 2x squared plus 3x minus 20. Okay, now I want to complete the square on this. It's slightly more complicated, this one, because I've got that 2 there, and it's going to be annoying because I've got an odd number there on my x as well. It's very annoying. But anyway, it's going to be a little bit messy then. So if I factorize the 2 out of the first two terms, and it really doesn't want to come out of 3x, but we're going to have to make it if it likes it or not. So I'm going to factorize 2 out of 2x squared. That leaves me with x squared. If I factorize 2 out of 3x, it's going to be 3 over 2x. Does that make sense? Because 2 times 3 over 2 is 3, isn't it? Okay. So it didn't really want to come out of there, but I just kind of made it. And I've got that minus 20 on the end. Okay. So then, when I move into completed square form, I've got to take half of the coefficient of x, don't I? So that's going to be 2 lots of, I'm going to change that to x plus half of 3 over 2 is 3 over 4, all squared. And then I'm going to minus the square of that thing there that I just wrote down. So it's going to be minus 3 squared over 4 squared. Which is actually, I'm just going to write it down actually. I'm going to work it out and write it down. So 3 squared is 9 and 4 squared is 16. Okay, and that's still inside the square bracket. Okay, now we need to pop that 9/16 out of the bracket. But if I take it out of the bracket, because I want to join it up with the 20, it's going to get multiplied by that 2 along the way, because at the moment it's 2 lots of. whatever's in that bracket. So that 9/16 is going to get doubled when I take it out of the bracket. Okay, so taking it out of the square brackets, it's going to double up. So that is going to give me 2 lots of x plus 3/4 all squared. Now if I take the 9/16 out, it's going to double up, and double 9/16 is 9/8. Okay, just multiplying, you know, 2 times 9 is 18, it'd be 18/16, then you're going to cancel through 2 top and bottom. It's going to give you 9/8. Easier just to halve the denominator, that's the same thing, isn't it? So that's what I did in my head, I just halved the denominator and got 8. Right, so then all we need to do now is combine those last 2 terms then to find b. So that's going to be equal to 2 lots of, and just dispose of those square brackets now, they're not doing anything anymore. So it's 2 lots of x plus 3/4 squared, and then I've got minus 9/8 minus 20. So how many 8s in 20? There are 20 times 8, so that's 160 8s in 20. So it's going to be minus 9/8 minus 160 which is minus 169 8. Okay, and that's it. It's not very nice, but that's it. 2 lots of x plus 3 all squared. So that's 2 lots of x plus 3/4 all squared minus 169/8. Part B says Charlie, Dev and Eve all attempt to sketch the graph of 2 lots of 2x minus 5, x plus 4. And there are their various attempts there. Whose sketch is the most accurate? Write down the properties of the graph that you use to make your decision. Okay, so we've got the graph y is equal to 2x minus 5, x plus 4. I think the easiest way to check these graphs is to find the intercepts. You can see this graph, these graphs all got kind of 3 interesting points. You've got your 2 x-intercepts where it passes through the x-axis, and you've got your y-intercept, and the same on here, look. So if we can find the x-intercepts and the y-intercepts and compare them to these 3 graphs, we should be able to work out whose is whose. Okay, so first up, to find the x-intercepts, we're going to let y equal 0. So when y is equal to 0, because the equation of the x-axis is y is equal to 0. So when y is equal to 0, we're going to get 2x minus 5, x plus 4 is equal to 0. So that means that 2x minus 5 must be equal to 0, because I've got 2 things multiplied together to give me 0, then one of them had to be 0 to start with. So that means 2x equals 5 and x equals 5/2 then. Or I've got x equals minus 4. Okay? So that means one of the x-intercepts has to be positive and one has to be negative. Okay? So that puts Eve's sketch right out then, isn't it? Because she's got 2 negative x-intercepts. So it's definitely not Eve's. Okay? My feeling is it's going to be Charlie's, because Charlie's is, can you see it, like the positive one is closer to the axes than the negative one, whereas Dev's is the other way around. And if you look at I've got roots at minus 4 and 5/2 is about, what, 2.5. So we're expecting the positive root to be closer to the axis. 2.5 is closer to the axis than minus 4 is. So I'm already thinking it's Charlie's. Do I need to do anything more than that? I think that's fine. I think that's enough to say for sure that it is Charlie's and not Dev's. So I'm gonna say that's enough info. I'm not going to do anything more. You could, if you wanted to be super sure, you could complete the square and see, you know, which side of the axes the root was to decide between them, because here one is positive, one is negative. But I can do that just from these 2 values. That seems like more work than I need to do. Okay, so I could do that. That would kind of like nail it, but I can also do it from those two roots as well. So I'm going to say that Charlie's sketch is the real one, because graph has roots at x equals 5/2 and x equals minus 4, i.e. 1 positive and 1 negative. Okay? Further, the positive root is closer to the y-axis as 2.5 minus 0 is 2.5 compared to 0 minus -4, which is 4. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.